is the rule. What's the rule, India?
You got the little brackets, they have to have the same amount,
This is 3.5.
right?
That was 3.5.
They get it wrong.
What's the rule?
They get it wrong.
Most have same dimensions.
Yeah.
But what?
What's the rule? I said it on Monday. It's the major rule. It's the one thing that if you're going to take away from matrices, it's the one thing. It's the one thing.
Oh yeah, that's the two brackets, not the. That's right. Yeah.
That was another rule.
Wait, hold on. Look at that thing I might have written down.
Oh, you wrote it down.
Let's see. Dimensions and feet is eight. I think I said that.
Let's don't close that folder yet.
I'm not going to close no folder. I'm just waiting.
What's the
Oh, I forgot.
Wait.
The one thing that you should take away from Monday is everything that has to do with matrices.
There's no
Rows by columns. Thank you, Luke. Rows by columns. Rows by. Oops, that's not a C. I have no idea what that is. Columns. Okay. Rows by columns. Okay. Now, that's going to come into play huge today. Okay? Because it's the basis for multiplication of matrices. Okay? What? Okay? So what's gonna transpire today is you are going to take the rows of the first matrix and you are then going to multiply that by the columns of the second matrix. Okay? That is how you multiply. Now, because you are going in that specific order, I have to tell you this next little pertinent piece of information. Order matters. Okay? The order that you multiply a matrix together matters. Okay? What I mean by that is, if you're talking about just numbers, okay? 5 times 2 is 10, right? 2 times 5 is 10. Order doesn't matter in scalar multiplication. And when you are just multiplying numbers, order doesn't matter. Okay? But when you are multiplying matrices, order matters. Because you're taking the rows of the first column times rows of the first matrix times the columns of the second. Rows by column, order matters. So, step number 1 says, all right, let's figure out how to determine if we can multiply matrices. Okay? And the first thing that you need to do, it's step number 1, is you need to look at the dimensions in order. Okay? When you look at the dimensions in order, left to right, the middle 2 dimensions, these 2 right here must be equal. If those two numbers are not equal, you cannot continue. You are done. Okay? It's not possible to multiply those matrices together.
Are you saying that those are the matrices? Like where you get the 3 times 2?
So the dimension, so 3 by 2 would be the dimensions of the first matrix.
Gotcha.
2 by 1 would be the dimensions of the second matrix.
Okay.
Okay? So if those middle two numbers are different, can't go on. And your answer then would be not possible. Okay? The cool thing is that if those two numbers are the same, then your answer, the resultant matrix, is going to be the numbers that are left over. So if this were a particular case, we had a 3 by 2 times a 2 by 1, we could multiply that together and we would get a 3 by 1 matrix in the end. Okay? Questions on that? Remember, dimensions are rows by columns. Okay? So, what are the dimensions of the answer matrix, the resultant matrix, if you will, for this particular problem? Okay? So I first look at the middle two numbers. Those are equal. So I can multiply. Okay? So then I look at my outer two numbers to get me the dimensions, and the dimensions will be a 2 by 5 matrix. Okay. Can I multiply? No. As it is, I cannot multiply it. So my answer here is not possible. No solution means that you went through and you were able to solve the problem and your answers just didn't work. Okay? You can't even get to that point with this because it's not possible to do. Okay? Now, as I said before, order matters. So if I flip-flopped those around, if I went a 3 by 2 matrix times a 2 by 2 matrix, is that one possible? Yeah. So the order matters because this one, now these two are equal, and so the resultant here then would be a 3 by 2 matrix. Okay. Just by taking the matrices and reversing their order, now it becomes possible. Okay? You won't have to do that though, because you would just quit after not possible. Okay? So, step number 1 is find the dimensions of the resultant matrix if possible. So, what is the dimensions here of this left matrix? It's a 3 by 2. There are 3 rows and 2 columns. What is the dimensions of the right matrix? Two by 1. 2 rows, 1 column. Can I multiply those two matrices together? Yes. And the resultant matrix is going to be It's going to be a 3 by 1. So what I recommend you do then, at least until you get a little more comfortable, is I recommend you draw a big old 3 by 1 matrix. Okay. Now, use the address of each resultant element to set up multiplication. This is row 1, column 1. Correct? In my resultant matrix. So that tells me then that I am going to take the first row of my left matrix and I am going to multiply it by the first column in the second matrix. So that becomes 5 times negative 2 plus 3 times 3. I take this number and I multiply it there. I take this number and I multiply it there. And I add those two together. This then is row 2, column 1. So I am going to take the second row times the first column. So that's going to be negative 1 times negative 2 plus 2 times 3. Take that number, multiply it there, multiply those two together, add them. This is row 3, column 1. So I am going to take the third row times the first column, negative 4 times negative 2 plus 0 times 3. There, and there, add that together. Add. Add.
No matter what.
Okay. So this becomes negative 10 plus 9. This becomes 2 plus 6 and 8 plus 0. So my answer, my final matrix, is going to be negative 1, 8, and 8. Okay. Do one more together and then I'll give you a couple to try on your own. Okay. So, first step. I've got to this is a 2 by 2 matrix. This is a 2 by 2 matrix. Are they multipliable? Yes. And what is my result? It's going to be a 2 by 2. So I'm going to make myself a ginormous 2 by 2 matrix. This is row 1, column 1. Right? So that tells me I take the first row times the first column. 4 times 5 plus -3 times -1. Row 1, column 2. I take the first row times the second column. 4 times 0 plus -3 times 3. Row 2, column 2. Second row, first column. Stop yelling at me, Swan. I can make a mistake once. Class period. 2 times 5 plus 1 times -1. Row 2, column 2. Second row, second column. 2 times 0 plus 1 times 3. So that's 20 plus 3, that's 0 minus 9, that's 10 minus 1, 0 plus 3, 23, -9, 9, and 3. Ready to try one on your own? Try it. 3 rows, 1 column, 1 row, 2 columns. Multipliable? Yep. Result? Going to be a 3 by 2. So row 1, column 1 is going to be 5 times 2. Row 1, column 2 is going to be 5 times -4. Row 2, column 1 is going to be 6 times 2. Row 2, column 2 is going to be 6 times -4. Row 3, column 1 is going to be -2 times 2. And row 3, column 2 is going to be -2 times -4. negative 20, 12, negative 24, negative 4, positive 8. Question. Try that one. What's the answer? Not possible. Dimensions of the first one, 2 by 2. Dimensions of the second one, 3 by 2. Middle two numbers, not the same.
You should just make a test of those.
Okay? Okay? Not possible. Okay? So, part of your homework tonight is going to be, they're going to give you like 4 different matrices. Book likes to make problems like that, where they give you like 4 matrices, and then they say, find A times B. Okay? Or they say, find B times A. Okay? So, what I'd like you to do now is I'd like you to find AB and BA. All right, so A is a 2 by 3 matrix. B is a 3 by 2 matrix. Those can be multiplied, and I end up getting a 2 by 2 matrix. Okay? So, first row is 1 times 6 plus negative 3 negative 3 times negative 5 plus 7 times 3. First row is 1 times negative 4 plus negative 3 times 2 plus 7 times 1. Second row, negative 1 times 6 plus 2 times negative 5 plus 0 times 3. Negative 1 times negative 4 plus 2 times 2 plus 0 times 1. So that gives me 6 plus 15 plus 21, negative 4 minus 6 plus 7, negative 6 minus 10 plus 0, 4 plus 4 plus 0. $21.42, negative 10, negative 3, negative 16, 8. So I got the matrix 42, negative 3, negative 16, 8 for matrix AB. Agree with that? Okay. Reset ourselves. BA, now this is a 3 by 2 matrix times a 2 by 3 matrix. So that's going to give me a 3 by 3 matrix. So let's see if I can move this one over. Will help just a squudge. Oh, now I can't see. Gotta be able to see. 1, 2, and 3. 1, 2, and 3. 1, 2, and 3. So, first row is 6 times 1 plus negative 4 times negative 1. Then we've got first row 6 times negative 3 plus negative 4 times 2. Ooh, run out of space.
Where are you getting these numbers?
Rows by columns. Rows by columns. I'm taking rows of the right one times the columns of the left one. 6 times 7 plus negative 4 times 0. Now we go to row 2. Negative 5 times 1 plus 2 times negative 1. Negative 5 times negative 3 plus 2 times 2. Negative 5 times 7 plus 2 times 0. Now we go to the third row. 3 times 1 plus 1 times negative 1. 3 times negative 3 plus 1 times 2. 3 times 7 plus 1 times 0. Okay. So then that becomes 6 plus 4, negative 18 minus 8, 42. Negative 5 minus 2, 15 plus 4, negative 35. 3 minus 1, negative 9 plus 2, 21. So that's going to be the matrix 10, negative 26, 42, negative 7, 19, negative 35, 2, negative 7, 21. Okay? 2 reasons why we did that one. 1, great. Great multiplication. It's good practice for you. And 2, it hammers home the point that order matters. Okay? If these were 2 numbers, we'd get the exact same thing no matter which one multiplied first. Okay? But in matrices, when you reverse the order, you get something that is totally different. Okay? Totally different when you multiply by something in a different order. Okay? Here is your homework for this evening. Due tomorrow. Monty, what else were we going to remind me of?